Okay, thank you everybody for coming here. So as Nick mentioned, I'm Disha Gosalia, and I work for GE, General Electric. My team is basically responsible for supporting our industrial IoT platform. So today I'm going to talk to you about how we use New Relic to monitor this platform, and specifically, how do we use that in incident troubleshooting? Okay, so first of all, when you think of General Electric, I think most of you, think of jet engines, MRI machines, or even refrigerators. But I think very few know that GE is also a $4 billion software company. We have almost 26,000 employees today that work in some form or the other in creating, selling, and supporting software products. And we're doing all of this with our industrial IoT platform called Predix. So what is industrial IoT? I'm sure everybody in the room is familiar with consumer IoT. When 4 billion people are connected together through social media, like Facebook, it's done something to the commerce industry. That's exactly what industrial IoT is planning to achieve. Connecting 20 billion machines together is then going to unlock, and you see the numbers up there, $32 trillion of opportunity. And yes, it's $1 trillion. I find it takes at least $1 trillion for people to sit back up in their chairs and listen. And then there is a projected $500 billion of investment that's going to happen on it to build software solutions on the platform. But while investing in industrial IoT may be easy, supporting and using it is certainly not. So there's a couple of really big challenges here. One is lack of interoperability between the systems. So the machines don't have a code of how they communicate with each other. There's no standard protocol. And secondly, there needs to be a very high degree of availability and security in this system. So unlike consumer IoT, you can imagine for industrial IoT, if you lost few seconds of data, while you are optimizing a jet engine fuel efficiency or transmitting your patient's MRI scan, it can be serious. So having high availability, resilience, and security, is super important. So that is, definitely, a challenge we have to overcome. So this is our environment. Along with all the challenges that we have in this system, the environment is super complex as well. We have various machines and connected assets that we call live on the edge. There's edge computing. There is some computing that happens on the edge, and then part of the data then has to transfer over to our cloud, what we call our Predix platform. It's a highly dependent environment of microservices. And on top of that then lives the applications. And this is where application developers of the IoT world, industrial IoT world, develop apps that provide productivity gains, to the machine. So they basically help predict the future. Like, how can you assure 100% optimization, out of your machines, out of a jet engine, out of a windmill, out of a power turbine. And the data in the cloud that gets transmitted through this complex system then also has multiple layers, and it's built on several microservices. So today in our platform we have it runs across 8 global data centers. It's private and public cloud. My team supports about 125 different applications that are built on almost 400 microservices. And then there is this interdependency of services, of how these applications interact with each other and the services and the layers that they depend on. So with the challenges in this space, as well as the complexity of our system, it became very evident to us here in G customer support that we needed to transform. The conventional ways of providing technical support will not work, right? We had to reimagine ourselves. We had to transform. So we focused on three main criteria here. So first is supportability. How do we build supportability into our products? So let's design our products with supportability in mind. So it's just easy to support them. Connected. We needed to have an integrated system of tools and processes that everybody can use. So from our customer to our support engineers to our developers, they should be able to use those tools and systems. And automation as well. So we use tools like New Relic to automate and have system and operational automation for scale. So our operational tools environment basically consists today of several monitoring tools, and New Relic being the prime one that we use for troubleshooting within support. The alarms from these tools then flow into what we call as our single frame of glass. So this is where our operation teams monitor these alarms to find out if there are any critical alerts that we need to work on. The critical alerts then from there use our on-call management system. We use PagerDuty here to get to the right team that is responsible for that particular service, that particular microservice. We also have a chat bot that we've integrated with our tools that our incident commanders run our outage management and our outage bridges from. And all of that then flows into our incident tracking, our case management system that we use ServiceNow for, all with the end goal of meeting our customer KPIs. So this tool integration, this tool simplification, is definitely one of very key areas that helped us with transforming our support journey. Now, while we had this really great platform, a product that is going to solve some real world problems. And it was resilient and scalable, so it could scale, have high availability. We knew that supporting it is not trivial. And I think that makes the job of people like us in support and operations interesting. So let's look at the KPIs that we kind of decided to focus on here. We had to meet and exceed our availability targets. So, what is our availability? How do we track it? How do we, make sure we exceed it? Improve our mean time to detect. So if we have to meet our availability targets, the most important thing here was to kind of understand where the problem is coming from, so our mean time to detect. Reduce major incidents. So we didn't just need to solve our problems, but we had to be proactive in identifying problems before they occurred and prevent them. And improve our monitoring percentage. So that was again a key KPI. I want to look at like the incidents that we get here in support. What percentage of that are we able to catch via our monitoring systems? So we proactively know it before our customers and our users do. So that's where we realized that without a single coordinated program, it's going to be fragmented, and our customers are going to pay the price. So in customer support, we actually decided to take kind of this matter into our own hands. We took our KPIs and went to our CTO and told them, we need a timeout. We need 6 weeks of your engineers' time to work along with us so we can proactively build supportability into our products. And we had very specific exit criteria there. Number one, we wanted to make sure that every service, production service on our platform has an end-to-end visibility. So they have a health check, and we're able to see its performance at any time live. We have smoke tests, so we have ability to validate what's going on with that service, detect failure modes and prevent them, which means we have thresholds and SLAs. So before the problem actually manifests itself on the user side, we're able to catch them and prevent it. And then, we need to tie all of that together through our operational maturity and automation. So what I'm going to do here is go through some very specific use cases that we partnered here with our friends here in New Relic to focus on these KPIs. So I'm going to walk through 3 specific use cases. What was it before what we call the POE, program operational efficiency? What was our challenge? And then what did we do with New Relic, how to solve it, and then what was the outcome? So problem statement 1, let's focus on the first KPI I talked about earlier, our availability, right? So for us to improve our availability in this stack of microservices and hundreds of applications, we could not be manual. It was very important that we could visually able to see whenever there is a failure, where is the root of the failure coming from. So kind of having our eyes kind of an end-to-end health of the service. And so that would help support decrease their mean time to detect, our MTTD. So for that, the actions we took is we implemented our dependency charts through service maps on New Relic. We leveraged their insights dashboards. And then we built automation on basically when we get alerts, how we run our operations and our outages. So let's walk through this example. One of our customers, they sell elevators, a big customer out of the Europe region. They purchased us back early in the year, and in their pre-production environment, I think this was back in April, the availability came out to be like 97%. They were going in production July, so we just had a few months to get a game up. This was a custom app that, mind you, they had built on our industrial platform using a bunch of our services to monitor the health of their elevators. So we had to get this availability up. So what did we do? The first thing we did is we created these dependency charts in New Relic's APM application. Exactly what are the microservices does this custom app depend on? And so it was very easy to visualize whenever there was a failure, for our support engineers, for our operations engineer, on where the root of the problem came. Right? So example over here, the device could not be detected, well, because there was a dependency, failure in the certificate service. So instead of going through service by service troubleshooting, it was easy to see through the dependency map, where the failures were occurring. Alerts. Before our program, we got one alert on the failure. So if the device could not be enrolled, we got a device enrollment failure. And again, the mean time to detect was higher because the engineer had to go and troubleshoot each layer. After we implemented the dependency charts and the alerts on top of it, we got a bunch of alerts. So that's where we could do alert correlation to see that, well, device enrollment is failing, because the certificate service is failing. And it was easy to pinpoint to the right team and the right service that we could bring on to solve the problem. And then we had this insights dashboard. This is one view of all the dependency for that application that we could see in kind of one screen. So if there were failures, you could easily pinpoint, where the problem is coming from. What are the services that are healthy, which is the root service that may be experiencing some errors and some failures. Operational efficiency. So when we received an alert, the operations engineer would typically go through, several hundreds of standard operating procedures to figure out what do they need to do with this alert. We did a very simple thing, and honestly, I think this is so simple that I'm just surprised why we didn't think about this earlier. Well, just embed what runbook or standard operating procedure they need to look at to solve that problem. So now we have, with every alert, we have a standard operating procedure that an engineer can just click through as soon as they get an alert, and well, they know what they need to do to either recover or who next to bring in to solve the problem. Along with that, I talked about the chatbot earlier, and in fact, this was another, though the tool is not New Relic, we learned from New Relic. We visited New Relic's Portland engineering office, and they actually use Slack as their chatbot to run the incident commander process. We integrate that with FlowDoc. It's just a very simple coffee script that you can get from GitHub. So now our incident commanders that are getting these incidents, they just need to be on one screen, and the chatbot is kind of their assistant. So in this case, well, for resolving that problem, they know that they need to bring in the time series team. All they need to do is page time series through the chatbot, and those guys get the page, and we don't have to, again, go through a different tool to find out who is the right team and the right on-call person to bring, which, again, 5-10 minutes saved there is huge in this space. So post doing this, in July, we were at 100%. It's a great win for our customer, and we obviously learned a few things in the process. All right, use case number 2, mean time to detect, and I talked about that a little bit. So the way we define mean time to detect here is the definition of mean time to detect is from the time we get an incident from the customer or an alert from the customer to the time support determines where the problem is, which service the problem is in. So we can either recover or bring in the right engineering team to solve it. So the problem here was we found out that places where our mean time to detect was really high is where we didn't report, our monitoring tools didn't catch that problem, but our customers had to report that problem. And that's where we found out that even though we had monitoring on health of our services, we didn't necessarily know or did the exact transactions, perform the exact transactions that our customers did. So that's where we went ahead and implemented journey monitors through New Relic synthetics, implemented composite dashboards so we could see this journey that our users are taking. So the synthetic transactions fire every few minutes, and then we're able to see anytime there's a failure. So that was, those were a few of the actions we took from mean time to detect. So let's walk. How did the troubleshooting process work? What did a typical engineer do before we had these tools or these journey monitors implemented? So our mean time to detect in this example was 55 minutes, close to an hour. It's huge. So customer filed a ticket, and most time then the support engineer had to translate that, try to reproduce that in their own environment to find what the error messages were. Then they would do this troubleshooting in the logs, investigate the log files on, what are the calls that are failing, which dependent services are failing. Once they find that dependent service, they have to kind of repeat that process for that dependent service. And so one by one, you kind of get that iteration, and you find your root service, and then you either recover or escalate. So it was a long and tiring process. After we implemented these journey monitors and the composite dashboards, we could actually do sort of click through to find out where the issue lied. So in this example, I know probably hard to read here, but we could, through our composite dashboard, see here's the specific application that is having an issue. You can double click into that application, and it will show you the list of microservices that application is made of, and which of those microservices is having a problem. So you kind of can see that it's down, and then you can click on that, and you actually get all the transactions that failed in that microservice. You can then double click on that transaction, and you get the exact the command or the query, the code command that you can take to reproduce the problem. You also get that error message there. In this case, it's showing that it was timing out. And then you have the run book and the SOP URL that the operations engineer can get to fetch to resolve and recover that problem. So from 55 minutes to 5 minutes, just by having some simple synthetic transaction and journey monitors implemented. Not simple, I know these guys sitting here who've implemented that, but great work, great results. So use case 3 was we wanted to proactively catch the problems before they occurred. One of my customers, when I was doing an onboarding call with them, I was showing them all these nice workflows of how you can escalate your problems to us and how we'll quickly respond. Just stopped me and said, Disha, I don't want to contact support. I want you to contact me. And this is the SaaS world, right? I want you to tell me if there is going to be a problem and that you're on it and you're fixing it. Like, sure, yes. That is where we have to transform here in support. We cannot be reactive anymore. We have to be proactive and predictive. So for that, we had to make sure that we have monitoring not only just on the health of our services, but we're kind of proactively setting thresholds, and we are finding out that an issue may occur on specific instances at the instance level, and recovering. So we implemented APM, New Relic APM, and APM alerts for that. So again, similarly, walk you through what was our problem or our challenge before we had this. an alert would fire. A support engineer would then investigate the log files. Let's say, an example, there were a lot of 502 timeout errors. When they investigated the log file, they came up with a hypothesis. Let's say only a few of the transactions were failing, not all. So the hypothesis there was, well, not everything is down, not all instances are down. There's maybe one faulty instance there. But we had no ability or no way to find out which is that instance. And in that time crunch, we just had to restart everything. We had to restart the whole app, which caused downtime. And at the same time, we couldn't collect specific data to find out root cause later. So a huge problem. With implementing APM and anomaly detection, we could easily get an alert whenever there was traffic that went above a certain threshold. And then we could also specifically figure out, going through the JVM browser, in that which JVM is a faulty JVM. So in this example, through the list of JVMs, we could kind of see that there is this one where the thread is here at 100% utilization. Through New Relic, we could then just take the thread profile, we could restart that JVM, outage averted, and now we also have data for root cause analysis to find out why it was stuck 100% in the first place. Another very important use of our APM in a multi-tenant environment was to detect sort of a noisy neighbor problem. So originally, if we had certain spikes in usage and traffic, we had to actually go to the network layer to find out what's going on. So we implemented per tenant monitoring through New Relic APM, where now we can see which tenants. In this case, you can see the yellow bar, tenant 2, has suddenly increased their usage. And so we now have specific data. We know what to do. We can contact that customer, or we specifically have at least a place of where to go to and what to do with that particular tenant. It also helped us with adoption metrics. So that was, again, a really beautiful insight of having this, which of our customers, which of our tenants are underutilizing us, overutilizing us, so we can, from a customer success perspective, work with them. So providing very useful business insights as well. Okay, so after the 6th week of our POE, we did see some really good turnaround in our KPIs. Because we integrated our system, had automation, added monitoring, we had a significant reduction in overall time to resolve our issues, so 66%. And this is over last quarter, so about 3 months. Reduction because of the anomaly detection, proactive alerts. We had a reduction in our priority 1 incidents, as well as we had high number of our incidents. So we actually jumped from 30 to 90%, so about a 40% improvement in all the incidents that were caught in our monitoring versus customer reported. And this is something, this metric I'm super proud of, is our mean time to detect, of how we improved that from over an hour to now just under 15 minutes, so a big 70% improvement there. All right, so what did we learn? We have some very key takeaways here, and the program is done, but we have to continue. We have to continue in our path and our journey of how, as we deploy more services, release more services, we continue to build on that. and we don't have to keep taking timeouts. So design your products with supportability in mind. This is one key area where, especially in support and operations, I would say, we are the owners along with engineering, right? Let's have very clear production readiness criteria of what is needed to go into production, and let's make sure that supportability features, we control them. Knowing your service health is half the battle. So, if you know what's going on when that customer call comes in, your engineers know the right thing to say, which is, we're on it. Plan for failure, that's inevitable. Any software or service is going to fail, and if we have planned for it, it's easier. Hold your product teams accountable to high operational standards. This is the transformation that is required as we move from the enterprise to the DevOps to the cloud world, where having that operational efficiency is just super critical. You're not just building, writing code, and then shipping it off. You have to operate it, and there needs to be excellence there. And then automation and process efficiency, wherever possible. All right, so we accomplished a lot here through our friends at New Relic, but we're not stopping. We definitely have more ground to cover. And we know we've started our journey. We know the roadmap, and we're just going to keep growing on that, building on that. All right. So questions? Yeah, and I have some engineers up front here, Ryan Jessel from New Relic, who's helped us build some of these capability, as well as Dewey here from GE. Yes?
Did you replace or are you replacing other monitoring tools? How do you deal with the too many tools problem?
OK, so the question is, did we replace or are we replacing monitoring tools? Yes and no. We're still in our journey there. So we do have, in several different layers, especially our infrastructure and our platform layers, various different monitoring tools. But for customer support, we did standardize that we are going to use New Relic for our troubleshooting. So what that meant is the other services, the underlying services in infrastructure and platform, had to integrate with us. So even if they use different tools, they had to send their alerts and their metrics to us, through the single frame of glass that I talked about. So, I think in a huge organization, you can probably never get to a single tool, but you need to have that ability where you're at least visualizing everything and you're integrating everything in one place. Any others? Hey, Dan, yeah.
Asked for the 6 weeks for the timeout. I'm curious what kind of response you got from the management team.
Yeah, so the question is, when we asked for the timeout, what response did we get? Well, actually, it was really clear. So we went with the right data, the right metrics. Here is where we are, and here's where we need to get to. Here is what we're committing to our customers. And when you have the right data, and very specific action items. Here is what we need from this team, and that's the results that we're going to get. So then the data made the decision clear. We also had a good leadership change. Our CTO joined us from AWS, and he's a big fan of operational efficiency. So that helps when you have leadership that believes in the same thing. Yes?
Our platform's a true multi-tenant environment as well, which obviously has huge benefits that a single deployment nationwide's connected. So we struggle with the same thing where all of a sudden we'll have a noise engine.
Yeah.
They tend to be, they don't tend to repeat on a regular basis. Sometimes there'll be a lot of load from that customer and then it'll disappear. Do you tie that into doing any sort of load balancing or anything? Is there anything that came with that, or is it simply that you transfer that customer now to another resource or something? Is there any automation built in there?
Yeah. Yeah, very good question. I'll repeat the question. So he wants to know about a noisy neighbor problem. When you detect a noisy neighbor, how do you balance the load? Do you just move them off, or do you specifically do some kind of load balancing? So at this point, where we found the most amount of issues here is we will just find that a customer suddenly just decided to do some kind of performance testing and increase their load out of nowhere. So the past, when we saw this, we actually just had to have a dialogue. Well, can we reschedule this at another time? But from an automation standpoint, yes, that is something that we are working on how we can sort of move the load over to a different instance. And I don't know, Dewey, if you have anything specific there of what we're doing in load balancing.
Yeah, so we do set up a microphone.
We can get it active. With the handheld mic?
Hello?
Oh, so we do set up a lot of alerts, and in this case, you would set an alert for your throughput or traffic, and because we tag each transaction with a tenant, we kind of know where it's coming from, and so we do have a lot of buffer room for spikes in traffic. So we do have a time to respond to that. So that's how we do it. We just have kind of a buffer room.
I would add real quick too,
Yeah.
there are customers utilizing a lower tier or free service of Predix, and those customers, I believe you have the ability to tune down if they're overutilizing the platform. And I don't know if that's an automated piece, but I know that's one of the rectification kind of levers to handle that load.
Yeah, it's a developer platform. We have a lot of free trial users as well, and so we have ability to do some of that too. Yeah. Thank you, Ran. Yes.
One other question. Did you get any surprises along the way? Anything that just really took your breath away that you weren't expecting?
So were there any surprises along the way? Yes. So, the mean time to detect, as I talked about, like just super close to my heart, I think that was by far probably the biggest surprise. I didn't expect that we're going to go from 1 hour to like just under 5 to 10 minutes. So it's just like, oh God, it's a complex system, and of course we're going to take time to find out where the problem is. And I had no idea that just doing a few of these simple things is going to really help us bring that down. And so yes, it works. Okay, so I think if there's nothing more, we're done. Thank you so much for coming and listening to me.